In the name of Almighty God, I'm Mahsa Sankoshi, and today I want to talk about the continuous of the observational signatures of pseudo axion resonances, transient geometry, and axion graviton conversion in string theoretic cosmology. So I want to continue the reading. This analytics approximation provides insight into the structure and weight of the resonance bands, complementing numerical analysis. They enhance pseudo-axion decays at resonance epochs, imprint distinctive signatures on gravitational wave backgrounds and photospectral, such as spectral peaks and polarization anomalies. Upcoming gravitational waves detectors like LISA, Einstein telescope, and the pulsar timing arrays will potentially detect the resonance-induced gravitational wave features, providing empirical tests of pseudo-axion scenarios. Our detailed mathematical analysis, combined with the intuitive physical interpretations and numerical solutions, firmly establishes pseudo-axion resonances as testable cosmological phenomena. Epoch-specific predictions and detailed resonance characterizations positions these results as valuable conditions to the ongoing exploration of fundamental cosmological process and axion phenomenology. Detailed analysis of pseudocycles from string theory and deep brain dynamics. So the axions arising from transient geometry structures termed pseudocycles provide a remarkable interplay between string theory, cosmology, and observational gravitational wave astronomy. This chapter expands the discussion by rigorously exploring the emergence dynamics and flattering of the pseudocycle explicitly derived from string theoretical considerations and deep brain configurations. Within string theory, axion-like fields energy naturally from compactification schemes involving Calabi-Yau manifolds. Pseudo-cycles arise when apparent topological cycles, initially robust due to non-trivial geometric configurations, dynamically change topology as modules evolve. Consider the 10-dimensional type IIB supergravity actions, such as supergravity actions is equal to 1 divided by 2 coed 10 dimensions to the power of 2 integrally the 10th derivatives of x and square root minus g multiplied by the bracket r minus 1 divided by 2 delta phi to the power of 2 minus 1 divided by 2 e to the power of 2 phi absolute f1 to the power of 2 minus 1 divided by 12 absolute f3 to the power of 2 minus 1 divided by 480 multiplied by absolute f5 to the power of 2, where the fields FP is equal to D CAP minus 1 are associated with Raman potentials. CAP and phi is the dilation field, compactifying on a Calabi-Yau threefold yields axion-like fields explicitly from the integrals of over p-dimensional cycles sigma p. Ix is equal to integrale. The lower boundary is sigma p CAP, with CAP explicitly antisymmetric, ensuring pseudo-scalar properties of the resulting axion fields. D-brain wrapping non-trivial cycles in the internal manifold explicitly induce gauge fields and geometric fluxes that alter the modular space structure dynamically. These effects create transient topological structures, pseudocycles, robust only temporarily until modular evolution flattens the geometry. Explicitly, the stability of the pseudocycles depends on the scalar potential arising from the D-brane action. SD brain is equal to minus TP integral d to the power of p plus 1 zeta e to the power of minus v square root minus determinant of the matrices GIB plus BIB plus 2p alpha purine FIB, where TAP is the brain tension, BIB is the nucleus 2 form, and FIB is the gauge field on the brain. Fluctuations in these fields explicitly generate and subsequently dissolve pseudocycles, resulting in modular dependent topological transitions. The flattering out of pseudocycles is explicitly described by a scalar potential governing modular fields. Consider a simplified scenario which the module-dependent scalar potential Vphi is equal to big root to the power of 4 multiplied by 1 minus cosinus phi divided by f cosinus um, phi divided by f, where phi and phi explicitly represents module fields controlling cycle sizes, and f sets the compactification scales. Evolution equations derived explicitly from these potential shock transient stable pseudocycles that flatten dynamically as fibrin plus 3 Fibrin plus derivative of the v based on the phi is equal to 0, and similarly for phi numerical solutions explicitly demonstrate cycle flattering correlated to cosmological expansion. The explicit presence of the pseudocycles alters the mass and coupling of the pseudoaxions, enhancing their decay rates at critical epochs. The effective action involving pseudoaxions coupled to gravitational fields is given by the S effective is equal to the integral the force derivative x multiplied by minus square root of minus g multiplied by minus 1 divided by 2 derivative of r to the power of 2 minus 1 divided by 2 m r to the power of 2 t r to the power of 2 plus alpha divided by 4 r prime, which modular dependent mass and mr to the power of 2t. So there is a figure 2 illustrates the schematic representation of cycle formation and flattering on modular space. This illustrative plot explicitly demonstrates the concept of pseudocycle emergence and eventual flattering as predicted by string theory and deep brain dynamics. The dashed blue contours represents the initial robust pseudocycle structure formed due to non-trivial topological configurations in the modular fields over cosmological time. Evolving modular fields and deeper interactions explicitly cause these transient topological configurations to dissipate. As illustrated by the solid red contours, the resulting flattened pseudocycle structures underscores the transient and dynamic nature of these topological entities, directly influencing pseudo-axion behavior and the corresponding observational cosmological signatures, where delta effective encapsulates non-perturbative string effects. Detailed mathematical analysis derived from string theory and the brain dynamics based on the reference 24 clearly illustrate the emergence and dynamical evolution of pseudocycles. These transient topological structures have significant cosmological and observational consequences, particularly through pseudo-axion decay into gravitational wave signals. Figure 2 and 3 feature gravitational wave observations over powerful tools to probe these string theoretical predictions. Modifications of gravitational wave signals from pseudo-axion resonances. Pseudo-axions arising from transient geometric structures and modular fields in string cosmology offer intriguing modifications to gravitational wave signals through resonance and decay into gravitons. Such modifications present distinct observational signatures potentially detectable by next-generation gravitational wave observatories, thus providing a direct link between theoretical models of high-energy physics and astronomical observations based on the reference 23. The presence of pseudo actions coupled to gravitational waves can be modeled by augmenting the Einstein-Hilbert action with a parity-violating interactions. S is equal to integral the fourth derivative x square root minus g multiplied by mpi to the power of 2 divided by 2 multiplied by r plus alpha divided by 4 multiplied by r are micro nu rho sigma are to the power of micro nu rho sigma, where r represents the soda action field and alpha characterizes the coupling strength. This coupling results in the modified propagation equations for gravitational waves polarizations H plus and H multiply H lambda plus alpha divided by mpi to the power of 2 lambda delta t delta z h lambda is equal to 0, and you can see that the figure 3 circle flattering overall cosmological time. The plot explicitly illustrates the dynamical evolution and the flattering cycles arising from the modally dependent topological transitions predicted by string theory and deep brain dynamics. Initially robust cycles represented by the high amplitude oscillations gradually flatten out due to the cosmological expansion and modular stabilizations. Exponential attenuation modulated by oscillations reflects realistic interactions between deeper intentions, geometric fluxes, and evolving modular fields. Such a process underpins the transient existence of pseudocycles, directly influencing pseudo-axion dynamics and their observable gravitational wave signatures, which lambda is equal to the plus and multiplications showing polarization dependent dispersion effects due to pseudo-axion induced parity violation. The propagation velocities of gravitational wave polarizations differ, producing an explicit polarization dependent phase shift. H lambda ZT is equal to H lambda to the power of 0 exponential I multiplied by chi z minus omega t plus lambda delta phi z, which delta phi z is equal to alpha divided by 2 mpi to the power of 2, and integral lower boundary is 0 and upper boundary is equal to z. The derivative of z prime, derivative of r based on the t, and polarization asymmetry explicitly emerging from the pseudo-axion gradients. We numerically solve the modified gravitational wave equations to identify explicit observational signatures. Figure 4 explicitly shows simulated gravitational wave amplitude modifications due to the pseudo-axion resonance. The following table summarizes key observable gravitational wave signatures modified by pseudo-axions. Detecting pseudo-axions induced modifications in gravitational wave signals would provide compelling evidence of high-energy physics phenomena in cosmological observations. Polarization-dependent modifications and spectral distortions offer distinct testable predictions for upcoming detectors, enhancing their observational sensitivity and broadening the scope of fundamental physics investigations. Now, I want to have an overview of the figure 2 and figure 3 and figure 4. Figure 3 illustrates cycle flattering overall cosmological time. The plot explicitly illustrates the dynamic evolution and flattering of pseudocycles arising from the module-dependent topological transitions predicted by string theory and deep brain dynamics. Initially, robust pseudocycles represented by the high amplitude oscillations gradually flatten out due to cosmological expansion and modular stabilization. The exponential attenuation modulated by oscillations reflects realistic interactions between deep brain tensions and geometric fluxes process and evolving moduli fields. Such a process underpins the transient existence of pseudocycles, directly influencing pseudo-axion dynamics and their observable gravitational wave signatures. So as you see in the figure 3, we have a cosmological time arbitrary units because there is no specific units in the x-axis, and in the y-axis we have a pseudo-circle amplitude which is differ from the minus zero point 0.6 until the 1. This plot illustrates the explicit pseudo-circle flattering over cosmological time, and you see that we have a strong fluctuations at the beginning and at the initiation, but at the end we have a constant circle amplitude. So I want to go to do the figure 4, which is illustration illustrating the localized polarization shifts in gravitational waves due to axion coherent mixing. The figure explicitly focuses on a narrow segment around the propagation distance, z is equal to 10, clearly illustrating transient but pronounced modifications of gravitational wave polarizations caused by localized axion current mixing effects. The dashed gray lines represents the original plus and multiplications polarizations waveforms unaffected by axions, while the solid blue and red curves depict the explicitly modified polarizations due to the axion interactions. The localized distortion visible in both polarizations offers a distinct observational signature potentially detectable by precise gravitational wave astronomy, and underscores the sensitivity of gravitational wave polarizations measurements to the axion and pseudo-axion physics. Now you can see that we have a narrow region gravitational wave plus polarization shift by axion mixing, and you see in the x-axis we have a narrow region gravitational wave multiplied by polarization shift by axion mixing, and in the y-axis we have an amplitude. So the axion interactions which gravitational wave represents an exciting frontier at the intersections of cosmological and cosmology high energy physics and observational astronomy. Explicit mathematical modeling and numerical predictions outlined in this work lay the foundation for targeted observational searches, significantly enriching the interpretive frameworks available to gravitational wave astronomy. Table 2 describes the observational gravitational wave signatures due to solar action interactions. You can see that in the left sections we have features, polarization shift, spectral distortion, and chip tripping. The modification in the middle column we have expected observation, differential phase shift, characteristics peaks, and altered frequency evolution. And the right sections we have sensitivity, LISA, ET, which is Einstein, LIGO, and CE, and PTA. Now I want to go through the string theoretics, derivation of brain effective potentials, geometric flattering, and flux dilution. In cosmological scenarios derives from string theory, key observable dependent on the evolution of internal geometric structures. Central among these parameters is the geometric flattering parameter n governing pseudo-axion evolution. Here we derive from first principles starting from the deep brain effective actions and internal Calabi-Yau geometry, the effective potential, the geometric flattering parameter n, and the flux dilation rate. Consider a DP brain wrapped on an internal cycle sigma p inside a compact Calabi-Yau manifold. Its dynamic follows from the Dirac-Born-Infeld or DBI action, which is a SDBI or a Dirac-Born-Infeld is equal to minus CP integral sigma p d to the power of p plus 1 set e to the power of minus v square root minus determination of the GIB plus BIB plus 2p alpha prime FIB expanding the embedding x set to the power of I around a stable solution x is 0 to the power of I. We obtain the effective potential by integrating out the internal coordinates. V effective x to the power of I is equal to TP integral the lower boundary is sigma p d to the power of p theta e to the power of minus v square root determinant of the GIB plus FIB expanding explicitly around the equilibrium. V effective x is equal to V effective x 0 plus 1 divided by 2, the second derivative of V effective based on the x, and the boundary is lower boundary is x0, x minus x0 to the power of 2, and etc. Defines explicitly the pseudo axion effective mass. Flux fields quantized on internal cycles determine energy densities. Consider a p-form a flux field FP whose quantization over a p-dimensional cycle sigma p yields the integral sigma p FP is equal to q, which yields FP is absolutely equal to q divided by L to the power of 2, with q is the flux quantum number constant and L is the characteristic internal dimensional scale. Thus, the flux energy density scale as a rho flux is uh, equal to the absolute FP to the power of 2 equal to Q to the power of 2 divided by L to the power of 2P if internal dimensions evolve cosmologically as LT is almost equal to IT to gamma. We obtain the flux dilation rate. Reflex is equal to r to the power of minus 2p gamma. The geometric flattering parameter n encodes the internal geometry evolution and flux dilution. By definition, we write the rho flux is equal to r to the power of minus 2n. Comparing this to the derived flux dilation rate from the above, rho flux is equal to r to the power of minus 2p gamma, which yields n is equal to p gamma. Thus, the parameter n emerged naturally and rigorously from internal geometry evolution. Gamma and flux field form a degree p. We show how the exponent gamma is derived from the internal moduli dynamics and a stricter consider moduli fields phi t, describing the size and shape of Calabi-Yau manifolds. Their effective four dimensions action is explicitly as it four dimensions is equal to integral the fourth derivative x square root minus g multiplied by r minus 1 divided by 2 micro and phi delta to power of micro rho phi and minus VFE. V potential VFE derived from the fluxes and geometric structures linearizing around the stable minimum phi 0 with mass MFE to the power of 2 is equal to delta to the power of 2 V divided by delta phi to the power of 2. We have explicitly these equations in 46, 47, and 48, which admits approximate solutions of the form of the delta phi t is absolutely equal to RT to the power of minus 3 divided by 2 cosinus m phi t plus delta. Given the geometric modulus sets the internal scale as LT is equal to e to the power of alpha phi is equal to e to the power of alpha phi 0 multiplied by 1 plus alpha delta phi, which yields LT is equal to I to the power of gamma, where gamma is equal to minus 3 alpha h divided by 2 mfe. Thus, gamma and hence n is derived from the fundamental string modulus equations of motion. Physically, the parameter n quantifies how rapidly pseudo-axion potentials flatten as internal dimensions expand. Observationally precise determination of n allows predictions for gravitational wave polarization shifts frequency modulation, and cosmological evolution modifications. For instance, gravitational wave passing through pseudo-axion region exhibit polarizations, asymmetrics, and frequency trips characterized by the parameter n, offering direct astrophysical tests of internal geometry predictions. Therefore, we derive from first principles the effective brane potential flux dilation rate and the key geometric flattening parameter n, clearly connecting internal string theoretic geometry with observable cosmological phenomena. This rigorous derivation demonstrates that n emerges naturally from fundamental string equations with clear implications for high-energy astrophysics and cosmology. Observational signatures of the string derived pseudo-axion in cosmological epochs. Pseudo-axion's scalar fields arising explicitly from the transient internal geometric configurations in string theory yields unique observational signatures in astrophysical and cosmological data. Unlike standard axioms, pseudo-axioms possess explicitly time-dependent effective parameters derived from the internal geometry evolution, providing unambiguous fingerprints of string physics in gravitational wave backgrounds and cosmic microwave anisotropies. In this chapter, we present detailed observational predictions at distinct cosmological epochs, highlighting novel signatures that uniquely distinguish string-derived pseudo-axioms. String-derived reactions resonantly decay or coupling during cosmological epochs, with internal dimensions flattening out. This transit coupling produces distinct observable astrophysical signatures, including polarizations, asymmetries in gravitational waves, frequency modulations, trips, and transit energy injections, modifying cosmic expansion rates. These phenomena emerge at epochs defined by the geometry flattering rates parameterized by n, and they produce signals at predictable stable amplitudes and frequencies. In Table 3, we summarize explicit numerical predictions for pseudo-axion observational signatures at various cosmological epochs derived from our string theoretic models. Parameters were computed using realistic internal geometry scenarios with typical values of gamma and n. These calculated numerical predictions are robust and directly testable by upcoming gravitational wave observations such as LISA and Einstein telescope, as well as precise cosmological surveys. Table 3 describes the numerical predictions for pseudo-axion observational signatures. You can see that in the left sections we have a cosmological epochs, recombinations, and this redshift is 1100. The gamma rate is 0.25 and rate is zero point 0.5, and observable signatures is polarization shifts, which is equal to 10 to the power minus 7. The next cosmological epoch is the structural formations, and the redshift is between the 30 up to the 100, and gamma is 0.35, and n factor is zero point 0.7, and the observable signatures is gravitational wave shear delta f divided by f is absolutely equal to 10 to the power minus 5. Late ionization, which is between 6 to 10, and the gamma is 0.45 and the n is zero point 0.9, which is illustrating as observable signatures gravitational wave amplitude modulation, which is equal to 10 to the power minus 6. And the next one is galaxy formations, which is between the redshift is between 1 up to 3, and the gamma is 0.50 and the n is 1. Gravitational wave polarization asymmetry is equal to 10 to the power minus 5. Present epoch is 0 for redshift, and the gamma is 0.55 and n is 1.5, and the observable signature is cosmic expansion rate shift delta h divided by h is equal to 10 to the power minus 4. The gravitational wave strength is modified when passing through the axion region at resonance approach. The modifications to the waveform is as here. So thank you so much for watching my tutorial video until the end. If there is any simulation for this literature, you can find it from my github.com/masterscript, and also you can find in Kashi script or Safari script. Today is the 20th of July 2026. Time is near the morning.